Yaskawa. You are watching the IEC 61131 Basic Series. This section covers the monitoring features of MotionWorks IEC. Hi, it's Matt Pelletier. Let's use the project that we've been developing in the previous videos to see how to force inputs and outputs, adjust the value display for Lreal data, use the watch window, tooltip, and cross-reference. Let's start with forcing I/O variables. If you've done everything according to best practice, and as we explained in the previous videos, you will have your I/O variables in the global variables list. And it involves, as outlined here, it involves double-clicking on the side here in debug mode on the row header. And if it's an I/O variable, you will see force and reset force. So let's take a minute here to go through and do that. In all cases of monitoring, it is only possible when you have debug mode activated. So let's go up here to debug mode, turn that on. And we can see here now that DI0 that we created in the previous video is not on, but we could force it on, force it to true by double clicking and clicking on force. So now the input remains off, but as far as the program is concerned, now it's on. And this can be done with outputs as well. You can see right now output 0 is on. I can go into force it and force it to false. And that does affect the output, forces the output to false. Now, what about this variable here, gGateOpen? Can we force this one? Let's double click on it. You'll notice that it's not possible. It's grayed out. And what do you think the reason is for that? And I'll tell you the answer. And the answer is that this is not an I/O variable. Only I/O variables with an address can be forced. So just to reiterate that, if there is an address, then it is an I/O variable, I or Q for outputs, and then it can be forced. If it is not an I/O variable, you can still overwrite, but realize that when you do that, the code itself may turn it off, and so you may not see any change happen. If the code is writing to that variable, writing it true every scan, then it's not really going to have an effect of overwriting it to false, as you can see here. It seems like nothing happens, but you have to realize that in the main POU, this variable is being written at every scan, and we'll never be able to beat that. Additionally, in the global variables, you probably noticed that when we forced an input and forced an output, it turned it pink. And anywhere you see a forced input or output, go here to the inputs, you'll see the pink highlight. And this happens, by the way, you can force also in the code. You don't have to be in the variable list. Just double click on it and force it, either force it high, force it true, or force it false. And that's what we're illustrating on this page of the presentation. So pink highlight means force. And so what's really happening when you force an I/O variable? What it means for inputs is that regardless of the state of the electrical circuit in the input module, and regardless of the state of the input module, we're going to leave or force that input variable to be held at either whatever the value is that we're forcing it to. In the case of a digital input, that's true or false. So when a variable is forced, the processor does not truly see the input state of the real-world input, and the real-world output is not affected as a result of the code. So while the code here may set an output on, like we were doing, I forced it to be off, and then that force makes its way. So you can think of this as a block at the input module, and then for the output module, we're blocking really the code effect on that output variable. We're forcing the output variables in both cases. Now, since this is IEC basics, I probably should take a step back and just point out what's the use of forcing a variable, an IO variable. Why would you ever want to do that? And the most basic answer is just troubleshooting. We have this digital input module, and we have the a switch, there's a 24-volt supply. There are different mechanical things that can go wrong, or maybe you could call it electrical issues that could go wrong, and that will affect your processor and the code that you have, and you may just want to test what will happen if I turn this input on, assuming that we'll fix that in the future. And so to troubleshoot and cause the program to run regardless of any wiring problems, you can use force. And likewise for outputs, you want to just test, does this output even work? Will the relay turn on? Is it wired correctly? Then without worrying about, is my code running properly, you can simply force an output in order to test that real world device. When troubleshooting, or when you're done troubleshooting, you may have forced many inputs and outputs, and so it's useful to have and use what's called a force list. So anytime you're in the area where you could force the variable, you could also go into the info button, the force tab, and see a list of everything that's forced, and reset force list will clear all those out and put everything back to normal operation. Why don't we take a look at that now in the code? Practice makes perfect. So I'll double click here on DI00. Here's the debug resource window, and you can go here to this info and go to the force tab, and I can see here the different variables that have been forced. I could check one to reset it, or reset all of them in this list. And now when I click close, you'll see that everything goes back, no more pink, and we're back to normal run state. And interestingly, I said the term normal run state. If we open up the project control dialog like we have many times before, usually we're closing it, but if we open this project control dialog, we'll see the state here is run. If you go into force anything, you'll see that the resource state stays at run, but the color changes and it lists the word debug. And this state, called run in debug mode, has several limitations. First of all, understand that this force state is not saved in the project. If you were to reboot the controller or warm start it, you don't remain in the force state. So force does not survive warm start or cold start, and it's not part of your project. This is a temporary state of the controller. Another reason that this is important is that task instances will not be able to be deleted or rearranged. This is true anytime the resource window is open, but even if the resource window is closed, you can only copy task instances. What do I mean by that, task instances? If we were to close this resource, leave debug mode, and now go back to editing, and perhaps try to change some of these items. You can see I've attempted to move the task money, and it's happened as it has happened before. In previous videos, I've shown that this happens anytime you have the resource window open, but now we have the resource window closed, and it still happened. And the reason it happens is because we're in this run debug special state of the controller. So please understand that using force puts these limitations on the controller, and it's a good idea to think of force as something very temporary and not something to use continuously while you're developing your code. And this info button also gets us to the force tab and the force list. I can reset all the forces, and now with the resource window closed, I can remove this extra copy of the money POU, and I've restored my project how it was before. Let's move on now to the monitoring feature that has to do with the Lreal value display. I get this question all the time, so rather than delay that, let's just attack it right away here. And let's add a line here to the money POU. We wouldn't necessarily have to do this, but just to keep in line with what is planned, let's add a line here to calculate tax. And we'll add a variable called tax and tax rate. And I want to be able to show then the precision. Okay, so debug mode is off. I go to the money POU, and I wanted to add a line here called tax. Remember how to do this? You hit F5 to insert the variable tax. And I think I would like tax to be the Lreal data type. I did not precede this with G, so it's not intended to be a global variable. I'll use var. Tax syntax is colon equal as before. And then I want the variable above there called income. Hit F5 and type it. There it autofills. Income times, and I'll make a new variable called tax rate. So F5 tax rate. And maybe for this one, I'll give an initial value of 0.8. And let's click OK here. We need a semicolon for the end. And let's see if we can download changes. And close that resource. Go to debug mode now. On occasion, debug mode will seem not to work. And in that case, what you need to do is to close and reopen the worksheet. That can happen often when you play around with the tasks and their order, or the instances, I should say, within the task or the task order. So if you ever seems like debug doesn't work, close it here, and let's open it again. And now we see here the result for each of these results in Lreal. And the issue that comes up usually is the number of digits after the decimal point is very high. But this can be changed, which is the point of this here. We can change this with double clicking on the variable. And not only can you change the value, I think I actually wanted 0.08. You can also change the precision of how many decimal places will be shown. So often 2 is enough, 2 or 3. And you can close this here. And that will update globally throughout the entire project. We could change it from 2 to 3. You just type in a new number and close this window, and that will be reflected. You know, it didn't take my 0.8 because I didn't overwrite. 0.08. Overwrite. There, a little more reasonable tax. 80% tax seems a little bit too high. 8% is more in line. There. Now, also important here with especially structured text is the feature of tooltip. If you are to hover in debug mode over any variable in the line here, you'll be able to see its value. That's often very useful in structured text code. So here I am, I can hover over the tax rate or over the number for income, any of these. This also applies to ladder and function block language. Here it's pretty easy to tell, reset equals 0, but if I hover, I see also the data. Next up here is the watch window. If you're in debug mode, you can go to the view menu and view the watch window, and you'll end up with a customized list of variables from any POU all in one list. And you can have several lists throughout the different tabs in the watch window. So let's pull up the watch window here in our project. Under the view menu, you can see there's the watch window. Mine comes up here in the lower left corner. And how do we get anything in here? Well, the one way that works everywhere is you can right click, and when you right click in debug mode, you can add to watch window. and that immediately puts it in the list. So let's add a couple. Let's add max capacity, added to watch window. Maybe you need to know the number of cars, add to watch window. And the usefulness of this comes from being able to go to other POUs. Looks like I need to reopen a lot of these. You can see that to reopen, you just close them here. I think I'm going to close them all and start with money, POU. You can right click in text, add to watch window. Maybe want the tax rate in the watch window. Probably should have some inputs and outputs in the watch window. So look at our two inputs. And the output. And so as many as you want, you can see, and they can also be adjusted here. For example, I want maybe to change the max capacity from 20 to 10. I can double click right on the number and type in what I wanted. I wanted 10. So it gives you a little bit easier access now to have some type of panel. Perhaps these are the inputs you have for the HMI or the data from the HMI anyway. And you have many different tabs. Whichever tab you have up is the one that they'll be added to. So as I demonstrated, this right-click method is a good way to do it. It works from variable list. It works from code. I did not demonstrate the variable list. I can do that here in a minute. But there is a second way, which is drag and drop. If you just drag into the list, that works only from the code, not from the variable list. So let me demonstrate a couple more of those, and you guys should try that out also on your own. I'll take advantage of the opportunity to show also you can delete using delete or the delete key. Here, delete key, delete key. And I could have also gone to the global variable list and done a right click to add any of these, adding to watch window, add to watch window. What you may not do from the variable list is to drag and drop, but we can drag and drop very easily from the code. We could drag and drop this reset. Just drag it in there, it comes to the bottom of the list. And these tabs can even be renamed. You right click on the tab and choose rename. And so by changing the name, you could have a more descriptive watch page and have in a larger program an easier way to find the data that you need within the watch window. The watch window is part of your project and will be saved in your project. Next is cross-reference. Cross-reference means that we can find every place in the entire project that a particular item, such as a variable, has been used. And there are two major steps to use the cross-reference. One is the View menu to pull that window up, and also is the Build menu to build the cross-reference table that needs to be updated from time to time. So let's look at our cross-reference. Under the View menu, Cross-References window, and that put the Cross-References window right here. We also needed the Build menu to build the cross-reference. And that then puts data into this cross-reference window. When the window's up and it's been built, you can now click on any variable. And so within this complete alphabetized list, it will bring you to that place. So I clicked on G_gate open, and it's showing me here that I clicked on it. It's in the main POU. We're writing to it, and it's a coil. I could also see where this is being read from. So double click on that, and it opens up the usage of it and shows that here I am reading gate open to DO0. And that's what we're illustrating here on this page. Back and forth between clicking on a variable in the code and then double clicking on another usage of that variable in the code. It makes it easier to find how the code is working and what variables work with which. And one final feature here of cross-reference is the filter. If you were to right-click on the title bar of cross-reference, you'll see the option for filter, where you can select which items to show. And one commonly checked item is to show only selected variables. So let's do that. Let's put only selected variable. Makes it a little bit easier to use the cross-reference. When you right-click, choose filter, and then check only selected variable, and click OK. Now if I click on Gate Open, it only shows in the list Gate Open and does not show all of the other usages of all the other variables in the project. I might also add that cross-reference works fine also without debug mode, and this can be useful as you are coding to find instances, find usages of, and make the corrections as you go. So let me give you an example of using cross-reference. The main reason to use cross-reference is that when you are trying to find out what's happening in a program, it can be often very complex, especially if you haven't seen the program before, it's somebody else wrote it, or you yourself wrote it a long time ago, and you just don't remember how it works. Cross-reference can help you find just what you need to know. And here's an example. I'll go to the main POU, and I see, okay, there's a counter, and it's counting from G sensor. Well, what does G sensor come from? I click on it, updates my cross-reference. I go, okay, yeah, we're reading G sensor. Something's writing to G sensor. So double click on G sensor and opens it up. I say, all right, let's see. It's DI0 is writing to G sensor. DI0, you can click on DI0. Okay, that's an input. I can see it has an IO address. Okay, so there's an input right into G sensor, and G sensor then is used to the counter. Okay, the output of the counter is this full, and where does full go? Okay, it's being used right here as a read, and this goes to Gate Open. Gate Open, let's click on that one. You're right into Gate Open, but what is using this variable? And we see here it's an output. There's an output being written to based on the state of Gate Open. So of course we already knew all this, and this is a very simple example, but I hope that this shows how you can use cross-reference to trace through your code and find which variables are causing other variables to be written to and why certain blocks perhaps are executing given the current situation. Thank you for your attention here for this section on monitoring, and we will be using these tools from now on, and so you're welcome to play around with them, and as we use them in the future, then you'll know the full story and the full training on how to use them all. So please use them to your advantage to troubleshoot your code and to make your experience with MotionWorks IEC go smoothly.